Hello everyone, welcome to a new video. Today we are going to motivate a little bit our module in data structures and algorithms. We'll talk about what data structures are, what algorithms are. We're also going to talk a little bit at the high level about why we're using Python and C++ in this course. And we're going to see at the high level the topics that we are going to be covering. I am Dr. Francesca Giacai, and I am a faculty in the computer science department at the School of Computer Science at Carnegie Mellon University. Let's start with the very basics. Why do we care about data structures, and why do we care about algorithms? You'll often hear this term in your computing courses, in computer science courses, algorithms, right? So what actually is algorithms? We will define algorithms as a step-by-step process or a set of clear instructions that generally we follow or the computer follows to solve a specific problem or achieve a task. We have seen algorithms in everyday life in multiple scenarios. For example, when you go to Google Maps and you're looking for directions, how to get from one part of Carnegie Mellon to another part of Carnegie Mellon, Google Maps is going to tell you turn left, turn right, go straight. That is an example of an algorithm because it's a set of instructions, right? If you're into cooking and you're following a recipe, if you are doing your taxes and you're following the tax code, if you're knitting or if you're sewing, you're following instructions, all of those are examples of algorithms, right? So a step-by-step process with a clear set of instructions that allows us to achieve a goal, perform a task, or solve a problem. In addition to algorithms, what we talk about in the computing world are also data structures, right? And a data structure is a specific way of organizing data, of storing data, and being able to access data. Throughout this course, we will talk about different algorithms and different data structures, namely different procedures, right? Different step-by-step procedures, as well as different ways we can store, organize, and access data. And the reason we talk about algorithms and data structures together is because they are very, very interconnected, right? We often discuss about if data is organized in a certain way, if it's part of a data structure, what kind of algorithm can we actually apply to it? On the other hand, if I have a specific data structure, what is the most efficient algorithm I can apply to it? So data structures and algorithms are very, very closely connected together. And throughout the rest of this course, we will talk about them together. In order for us to be able to talk about algorithms, first we will need to cover a couple of more theoretical conceptual topics. First, we need to talk about efficiency and the big O notation. If you've never heard about this topic, that's totally fine. We're going to start from the very basics. But the idea is how good is a specific algorithm in terms of how much time it is taking to run and how much space it needs to run. So we're going to define those terms formally, and then we're going to see ways we can measure the time and space that an algorithm take. But in addition to that, as we're working with algorithms and data structures, we'll know how to use recursion. Recursion is a very popular technique that allows us to solve problems by delegation, which means that I am delegating a smaller version of this problem to somebody else, and they're going to solve it, give me the solution, and I combine it to create a bigger solution. That's a very brief, quick definition of what recursion is. When we cover the video lecture on recursion, I'll go into more depth. But in a nutshell, in order for us to be able to talk about data structures and algorithms, we'll have to talk about the big O notation and efficiency in terms of time and space, and we'll also be able to talk about recursion, and those are going to be two separate lectures that we will cover. In addition to those topics, right, efficiency and big O and recursion, there's a couple of other topics that we will cover throughout the semester. We will focus on algorithms that will allow us to search for elements. Those are usually called search algorithms, including linear search and binary search. We'll also focus on algorithms that sort data. We call those sorting algorithms. We're going to start from the basic elementary sorts and then see some more complex sorting algorithms like merge sort and quick sort. In addition to that, we will also certainly talk about various data structures, including lists, linked lists, dynamic arrays, stacks, queues, priority queues, and so on and so forth. So this is a bird's eye view of what to expect for the rest of the semester and the topics that we're going to cover. While a lot of these concepts are going to be discussed at the theoretical level or more conceptually, right? We will need to get some practice and hands-on experience with implementing algorithms and data structures in a programming language. And for that purpose, we are going to use both Python and C++. So as you'll see throughout the lectures, I will have an editor open. I will be working in Python and you can follow along. I will be working in C++. Those are two very important languages. Python tends to be a beginner-friendly language, but also extremely powerful with a lot of libraries. C++ has its origins and roots in the traditional C language. And a lot of the courses that you will continue taking at CMU will rely on your knowledge of C and C++. So that is the reason why we picked those two languages and why we'll do many of the implementations both in Python and C++. You may ask, what are the prerequisites for this specific course? I have listed a couple of them here. You will need to have some knowledge of C++ and Python. We will cover more in-depth knowledge, but any fundamentals of programming concepts, right, including data representation, variables, how to create and write functions, how to call functions, how to call methods, how conditionals, iteration, loops work. Those we expect you to be familiar with, both in terms of conceptually, right? What's a variable, what's a function, what's a conditional, how does it work, how does iteration work, but also more specifically how to implement those kinds of fundamentals in C++ and in Python. In addition to that, we also expect you to be familiar with pointers. While we will not be using pointers in Python, C++, like C, uses pointers. If you'd like a refresher on the pointers, please look at the pointers lecture from the module Intro to C, Introduction to C, that is provided as part of your academic path coming to CMU. But I would definitely do a refresher on pointers so that when we get to that part of our lecture, we are comfortable with that material. In addition to that, we will require you to have some basic problem solving skills in terms of how can we create a specific structure, or how can we implement a problem, or how can we solve a specific real life scenario. But we will be developing some of those skills throughout the semester. So in a nutshell, that's the intro for the data structures and algorithms module. I'm very excited to work with you all, and I will see you in the next lecture. Thank you.